Good day, everybody. How are you all? Hope you are doing great today. Today, we'll talk about hypothesis test for population proportion. So, I will share my computer screen with you first. Okay. So, here we are talking about large sample hypothesis test for a population proportion. As I mentioned before, hypothesis is an educated guess about a population parameter like population proportion because we cannot reach the entire population at one time. So we have to work with a sample. For example, considering a college, I may want to find out what percentage or what proportion of students at that college have laptop computers. So, since I cannot reach the entire population, I may have to work with a sample, simple random sample of say 100 students. I ask 100 students, how many of you have laptop computers? If 80% of them or 80 out of 100 say that they have laptop computers, then the sample proportion of success, because my success is to have a laptop computers, is 80 who have laptop computers out of 100 students who are surveyed. So my sample proportion of success is 0.8. From this, I will make an educated guess about the population proportion. And this particular section talks about how to test my educated guess for the population proportion. So the sample proportion is given by the symbol p hat. P with the thing at the top is called p hat, is number in the sample that possess the property divided by n. N is your sample size. Okay, so p hat serves as the basis for testing hypothesis about population proportion p. Notice the population proportion is indicated by the letter p without the hat. Large sample test is based on same properties of same properties of sampling distribution of p hat, okay, that were used to obtain confidence interval for p. If you remember, we had talked about sampling distribution of p hat is a bell-shaped curve. Okay, so we have p hat on the horizontal axis and relative frequency or probability density on the vertical axis. We get a bell-shaped curve at the base or on the horizontal axis is p hat. On the base, at that particular value of p hat, where the relative frequency is highest, is the center of the curve, and that central value of p hat is mu p hat. It is the center of the sampling distribution of p hat, and it is equal to population proportion, and the standard deviation of the sampling distribution of p hat, sigma p hat, is given by square root of p times 1 minus p divided by n. These two equations come from central limit theorem, which was used to calculate the confidence interval of p. Okay. So the key point to take away is the center where the relative frequency is the highest in the sampling distribution of p hat, mu p hat is equal to p, and the standard deviation of the spread of this curve is equal to square root of p times 1 minus p divided by n. Here p is the population proportion and n is my sample size. When n is large, the sampling distribution of p hat is approximately normal. These three results imply that the standardized variable z is equal to p hat minus p divided by square root of p times 1 minus p over n. So I'm comparing the p hat, the sample proportion, to the population proportion p and dividing it by the standard deviation of the sampling distribution of p hat. That is my z score as given by this equation tells me how many standard deviations of the sampling distribution of p hat away from the mean is p hat located. If the z score or standardized test variable, a test score or standardized variable score is positive, then p hat is greater than p on the right of p on the horizontal axis. And if p hat is less than p, that is on the left of the population proportion p, then the z-score is negative. So if the z-score is positive, it tells us how many standard deviations p hat is above the p. And if z is negative, it tells us how many standard deviation p hat is below the population proportion. So this has approximately a standard normal distribution, that is a z distribution. The standard normal distribution is z distribution, which is basically is a bell-shaped curve. The center where the peak is the highest for this curve is where at the horizontal axis z is equal to 0, that is mean is equal to 0 for the standard normal curve, and the standard deviation of the standard normal curve is 1. Okay. Test statistic, a value calculated using sample data. It is the value used to make the decision between rejecting and failing to reject H0. Okay. Remember, we talked about making decisions either we reject H0. We do that if there is enough evidence from the sample data to support the alternate hypothesis. Then we will reject the null hypothesis. On the other hand, if there is not enough evidence from the sample data to support the alternate hypothesis, then we do not reject the null hypothesis or fail to reject the null hypothesis. So decisions either reject the null hypothesis or fail to reject the null hypothesis. How do we make that decision? Based on our calculation of the test statistic. What is test statistic? It is a characteristic of the sample that we have collected. Basically, it's a z-score for the sample proportion p hat using the formula that we saw in the previous slide. Now, after we calculate the test statistic, we can calculate a p-value. Here, p stands for probability value. So it is a measure of inconsistency between the hypothesized value for the population characteristic and the observed sample. It is the probability, assuming H0 is true, of obtaining a test statistic value at least as inconsistent with H0 as what was observed. The p-value is also sometimes called the observed significance level. So, what is p-value again? So, after we calculate the test statistic, we found out what is the probability of obtaining a test statistic as extreme as what we have obtained, assuming that H0 is true. Okay, so that's why the second sentence is important. It is the probability, assuming that H0 is true. So, initially, assume that the value of the population proportion is what you have assumed, that H0 is true. And then we calculate the test statistic, which is a characteristic of the sample that we have obtained. And from that, we get a p-value or a probability value of obtaining the test statistic as extreme as what we have obtained, or more extreme, okay, at least as extreme as what we have obtained. Okay, so again reading, it is the probability, assuming that H0 is true, of obtaining a test statistic value at least as inconsistent with H0 as was obtained. So if the test statistic is too far away, okay, from the value that we have assumed in the null hypothesis of population proportion, if the test statistic provides from the test statistic, if we obtain a probability value for the test statistic, then if it is too far away from the assumed value of the population proportion, then We do not support 80, as you will see. So the p-value is the probability of obtaining a test statistic as at least as extreme as what we have obtained. Okay. The introduction of artificial intelligence tools such as ChatGPT has led has led to concern about how students are using artificial intelligence and whether it poses a threat to academic integrity. Researchers at study.com surveyed students and educators to gain insight into the use of AI in schools. The online article, Productive Teaching Tool or Innovative Cheating, states that over one third of the educators believe that ChatGPT should be banned in schools and universities. This statement was based in a survey of 100 educators, with 34 responding that they believe ChatGPT should be banned. Okay. So the critical sentences in this problem statement is the online article states that over one third of the education, over one third, that is more than 33% of all educators believe that ChatGPT should be banned in school and universities. And what was this observation or educated guess based on? The surveyed 100 educators, 34 responding that ChatGPT should be banned out of 100. Okay. Assuming it is reasonable to regard the sample as representative of educators, does the sample provide enough evidence in support of the claim that more than one third of the educators believe that ChatGPT should be banned in schools and universities? With P is the population proportion of all educators who believe that ChatGPT should be banned in schools and universities. The relevant results are the null hypothesis is status quo population proportion is 0.33. Alternate hypothesis is the claim that more than, that is why P is greater than 0.33. So we have sample proportion, which is X, the small number, which is number of successes out of a sample size here, 34. Educators thought so out of 100. So p hat is 34 over 100 as 0.34. So we calculate a test statistic for p hat equal to 0.34. So z is equal to test statistic. Basically, in the numerator, we are comparing p hat to the hypothesized population proportion in the null hypothesis, which is 0.33. P hat is a sample proportion, which is 0.34. Okay, 0.34 minus 0.33 divided by square root of 0.33 times 1 minus 0.33 divided by sample size, which was, I believe, 100. So how can I do this in the calculator? So in the numerator, it's 0.34 minus 0.33. 0.34 is the sample proportion. 0.33 is the value, hypothesized value in the null hypothesis. Okay, so 0.34 minus 0.33 is 0.01. That has to be divided by, so 0.01 we type in the calculator from the numerator divided by, okay, what we will do is we will put a left parenthesis in the division in the denominator, left parenthesis, then we will press the second button and x square button in my TI-84 calculator, which gives me the square root. So it will be 0.33, which is the hypothesized population proportion value, times left parenthesis 1 minus 0.33 right parenthesis divided by n. My sample size was 100. And then you put another parenthesis, right parenthesis, and calculate the z value, which is 0.2126. They got 0.20. Okay, so this is the test statistic. Okay, now we have to calculate the probability of obtaining a test statistic at least as extreme as zero point 0.2. Okay, how do we do that? Okay, the probability that the z value is at least as inconsistent with 80 would be observed if 80 is true. Is probability value a probability test statistic greater than zero point 0.2? Okay, so in our case it is 0.212. Okay, so what will we do? We have to calculate the area to the right of the test statistic, which is zero point 0.2. So we go to second, then press the worst key in the calculator, then go to number two, normal CDF. So we are calculating the area to the right of the test statistic, which in our case is 0.212, and upper is a very large number. So we press the second button and then the comma button on top of the 7 button in the upper, and then gets us the small capital E, which is exponent 99. That is 1 followed by 99 zeros. And since this is a standard normal curve, mean is 0, standard deviation is 1, paste, enter, and enter. And the area to the right of the test statistic, in my case I took 0.212, is 0.416. 0.416 is similar to 0.420 that they have obtained. The probability indicates that when p is equal to 0.33, it would be not unusual to observe a sample proportion as large as 0.34. What does it mean? So it means there's a 42% chance that the test statistic value, z value, would be greater than or equal to zero point 0.2. That is, it is possible to obtain a sample proportion as large as 0.34. Remember, we calculated the test statistic for sample proportion of 0.34, and that was the area to the right of 0.34, to the right of the test statistic, which is zero point 0.2, assuming the sample proportion of 0.34 and the population proportion of 0.33 hypothesized value. So it's a large amount percentage, 42% chance that Z can fall in that anywhere in that area from 0.2 to the extreme value on the right. Okay, high probability. When 80 is true, about 42% of all samples would have a sample proportion as large or larger than 0.34. This means that the sample proportion of 0.34 is reasonably consistent with the null hypothesis. Although 0.34 is larger than the hypothesized value of p equal to 0.33, chance variation from sample to sample is plausible explanation for what was observed. That is not convincing evidence. Okay, so we are saying there is a high probability of obtaining a test statistic as large as zero point 0.2 or getting a sample proportion as high as 0.34. Okay, but there is a sample to sample variability. So even though 0.34 itself is slightly larger than the hypothesized value of 0.33, this is because of sample to sample variation. There is not convincing evidence that the population proportion of all educators who believe that ChatGPT should be banned in schools and universities is greater than one third. In other words, what we are saying by the last two sentences is that there is not enough evidence to support the alternate hypothesis. Remember, the alternate hypothesis was p greater than 0.33. If there is not enough evidence to support the alternate hypothesis, the decision will be do not reject H0 at alpha equal, do not reject H0. Let's leave it like that. Okay. A decision to reject or fail to reject H0 results from comparing the p-value to the chosen significance level alpha. I have to remind you what is alpha. Alpha is the level of significance. It is 1 minus the confidence interval, confidence level. So alpha is the maximum probability of making a type 1 error. What is a type 1 error? Type 1 error is made when we reject H0 even though in reality H0 is true. That is, we keep the maximum risk of rejecting H0 when it is true at 5%. So here they're showing us a summary rule. So we will reject H0 if p value, the probability value of the test statistic that we'll calculate, is less equal to alpha. Then when we reject H0. And we fail to reject H0 if p-value is greater than alpha. In the last case, remember the p-value was 0.40 something. Okay, that is much higher. Usually alpha, the level of significance, is kept at 0.05. So if the p-value, the probability value of obtaining a test statistic as at least as extreme as what we have obtained is greater than level of significance, which is 0.05, then we do not reject H0, or we say fail to reject H0. Okay, the calculation of the p-value depends on the form of inequality in the alternative hypothesis. In this, they're showing us a particular situation where the alternate hypothesis is p greater than zero point 0.6. Okay, p is greater than zero point 0.6. Okay, and notice the region where we will reject the null hypothesis, or the highlighted area under the standard normal curve, falls in the right tail. Why it falls in the right tail? Because the alternate hypothesis direction is greater than zero point 0.6. Think of the two slanted lines which make up greater than sign. They meet at an edge pointing to the right, hence the rejection region is in the right tail. And this is the formula for calculating the test statistic. Remember, in the test statistic in the numerator, we compare the sample proportion with the hypothesized population proportion. That's why we have p hat minus zero point 0.6. And then it is divided by the difference in the numerator is divided by standard deviation of the sampling distribution of p hat, which is calculated assuming the population proportion, the hypothesized value of population proportion in the null hypothesis. In this case, they calculated the test statistic. It was 3.29. Area to the right of 3.29 is 0.0005. As I told you, most of the time, alpha is 0.05. That is the maximum probability of rejecting H0 when it is true. P is less than alpha. Decision is reject H0. Okay. With a partner, discuss the following. Be prepared to share your insights with the class. How do you think the procedure for finding p-value would be different if the test is two-sided test? When is a test two-sided? That is what we have to decide first. So here, the null hypothesis should be equal to, and the alternate hypothesis should be not equal to. Okay. So what we will do is the symmetry of the z-curve implies that when the test is two-tailed, the not equal to alternative. So if we look at a hypothesis H0p equal to zero point 0.3 and the alternate p not equal to zero point 0.3. We're not saying greater than or less than. Then it is a two-tailed test. Okay. And the z, the test statistic, can fall in any of the left tail or right tail. If z is negative left tail, then we calculate the area to the left of minus 1.75 as shown in this case. How will we do it in our calculator? Second verse 3. No, second verse 2. Okay. So second verse 2. Normal series. So we are on the left of minus 1.75. So on the left lower value is a very large negative number or a very small negative number. It's minus 1 E99. That's already in the calculator. The upper is where we stop is minus. This minus is next to the enter in the calculator, minus 1.75. And then Mean is 0 because it's standard normal curves. Standard deviation is 1. Paste enter and enter. And the area to the left of minus 1.75 is actually 0.04. And then we multiply it by 2. Why are we multiplying in the 2? Because the test statistic could have also failed on the right tail. Like here, they're showing z equal to 1.75. This only happens if the alternate hypothesis is not equal to. So if we multiply the area on the left tail by 2, we get the p-value or the probability value for a two-tailed test. So in this case, multiplied by 2, the p-value will be 0.08. Okay. Upper tail value, we look at the alternate hypothesis. If the alternate hypothesis, in this case, population proportion greater than hypothesized value, then it's a right tail test. It means the shaded area is the area of the rejection. Okay. Area of the rejection. And if the test statistic falls in the rejection region, the shaded region will reject the null hypothesis. In this case, we will calculate a p-value, which is the area to the right of the test statistic that we calculate. If the p-value is less than alpha, then we reject the null hypothesis. If the p-value greater than alpha, fail to reject the null hypothesis. Similarly, in the left tailed, when the alternate hypothesis HA p less than a hypothesized value, then the test statistic might fall in the left tail. So if the p value, which is the area to the left of the test statistic, is less than alpha or level of significance, we reject the null hypothesis. On the other hand, if the p value is greater then alpha. Remember, p-value in this case will be the area to the left of the test statistic. If it is greater than alpha, then fail to reject the null hypothesis. And for a two-tailed test, p-value is the sum of the area in the two tails like we just discussed. Okay, so upper tail test, p is greater than hypothesized value, and lower tail test, p is less than hypothesized value. Okay. So the null hypothesis is that status quo things as it stands today. Null hypothesis colon p is equal to the hypothesized value. Test statistic value is a characteristic of the sample that we have collected. How do we calculate it? We compare the sample proportion to the hypothesized value, assuming a bell-shaped distribution for the sampling distribution, and we calculate the standard deviation of the sampling distribution. So the Z will tell us how many standard deviations p hat value is above the hypothesized value. If the z-score is positive, if the z-score is negative, it tells us how many standard deviations you are below the hypothesized p-value. Okay. One thing, remember, we're talking about a large sample, so we have to make sure that these are valid. So p hat is a sample proportion from a random sample, and the sample size is large. How do we ensure that? We have to make sure that n times p, which is the number of success, okay? N times p, in this case, p is the hypothesized value in the null hypothesis. So n times p is greater or equal to 10 and n times 1 minus p is greater or equal to 10. If sampling is without replacement, sample size should be no more than 10% of the population size. So how do you conduct a hypothesis test? We describe the population characteristic of interest, state the null hypothesis, state the alternate hypothesis, select the level of significance alpha for the test, display the test statistic to be used with the substitution of the hypothesized value identified in step 2. Check to make sure that any assumptions required for the test are reasonable. Calculate all quantities appearing in the test statistic and the value of and the test statistic itself. So after we calculate the test statistic, which is a characteristic of the sample, we Want to find the p-value, which is probability of obtaining a test statistic at least as extreme as what we have calculated, assuming the null hypothesis to be true. If the p-value is less equal to alpha, then we reject null hypothesis. If p-value is greater than alpha, then we fail to reject the null hypothesis. Steps 1 through 4 constitute, so let's look at steps 1 through 4. They constitute a statement of the problem. Steps 5 through 8, they need to give the analysis, and then we come to step 9 where we make the decision whether to reject the null hypothesis or not to reject, and then we make a conclusion. Okay, so here is a problem. The report 2019-2020 college going rate for California high school students indicates that 63% of the students graduating from California high schools go on to attend a 2-year or 4-year college the year after graduation. This college going rate for students graduating from high school in Los Angeles Unified School District was estimated to be 52%. Suppose that the estimate of 52% was based on a representative sample of 500 graduates from high schools in the Los Angeles School District. Okay, so first we have to understand what's going on. So let's read it. The report indicates that 63% of students from California high schools go on to attend 4-year college the year after graduation. So the status quo, the population proportion is 0.63. On the other hand, they have a sample. They collected a sample of size. This college going rate was rate for students graduating from the college going rate for students graduating from high school in Los Angeles Unified District School District was estimated to be 52%. Suppose that estimate of 52% is based on a representative sample of 500 graduates. So the sample that they collected from Los Angeles Unified School District N is 500, out of whom 52%. So the sample proportion of success is 0.52. Okay. Is it reasonable to conclude that the population proportion of Los Angeles Unified School District high school graduates who attend college the year after graduation is different from 0.63? So as I said, the status quo null hypothesis is colon P equal to 0.63. Now we want to test the alternate hypothesis whether P is not equal to 0.63. Why not equal to? Because it says it's different from, it's not saying greater than or less than. So not equal to. Level of significance, they want us to select alpha is 0.01. Remember, the sample size is 500 and the sample proportion of success P hat is 0.52. So they will compare the p hat 0.52 to 0.63. Okay, so they calculate the test statistic by comparing the sample proportion p hat to the hypothesized value of 0.63. So how do we do this test statistic calculation on our calculator? On the numerator, we put a left parenthesis. P hat is 0.52 coming from Los Angeles Unified School District. Sample size of 500. Okay, so p hat is 0.52 minus 0.63 and then a right parenthesis to separate the numerator from the denominator. Remember, the z is a test statistic, is a standardized score, z-score for the sample proportion. So it has to be divided by or standardized by the standard deviation of the sampling distribution of p hat, which is second x square in the denominator after divided by second x square gives me the square root. Inside the square root, hypothesized value is 0.63. Then left parenthesis 1 minus 0.63. This is the value from the null hypothesis. Okay, and then that has to be divided by sample size 500. Okay, and then you hit enter, and your test statistic is minus 5.09. So, assuming the null hypothesis to be true, the sample proportion of 0.52 gives us a test statistic of minus 5.09. Remember, this is a two-tail test. So first we will find out what is the area to the left of minus 5.09 under the standard normal curve and multiply it by 2. So in order to do that, we do second verse 2. We are doing the area to the left of minus 5.09. So the lower is minus 1 E99, upper is minus 5.09. So minus is next to the enter, minus 5.09, mean is 0, standard deviation is 1, paste, enter, and enter. That probability value is very small. It is not 1.79. It is point followed by 6 zeros and then 179. Because it's a two-tailed test, we have to multiply it by 2. So the p-value in this case is point, decimal point, followed by 6 zeros and 3. It is much smaller than, of course, they did not give, they gave us a level of significance, 0.01. So this p-value of 0.000, 3 zeros, then 4, 5, 6, 6 zeros and 3 is much smaller than the level of significance of zero point zero 0.01. Therefore, the decision will be to reject the null hypothesis. And we will state that at alpha equal to zero point zero 0.01, there is enough evidence to support the alternate that the population proportion is not equal to 0.63. There is enough evidence to support the alternate hypothesis. At significance of zero point zero 0.01, you would reject the null hypothesis. P-value rounded to 3 decimal places is 0.000. Like I said, 6 zeros followed by 3 is the p-value, which is less than the significance level. Alpha is zero point zero 0.01. The data provides convincing evidence that the actual proportion of Los Angeles Unified School District graduate high school graduates who attended college during the year after graduation differs from the statewide proportion. Okay. Now I will discuss how to do the same type of calculation using a calculator. So we will get off from here and then work on a problem that, okay. So it says, if I can bring this down a little bit. Yeah, there you go. Okay. It says a teacher believes that 85% of the students in the class will want to go on a field trip to the local zoo. The teacher performs a hypothesis test to determine if the percentage of the sample is different from 85%. The teacher samples 50 students and 39 reply that they would want to go to the zoo. Okay. For the hypothesis test, use a alpha equal to or level of significance is 1%. So the let's do the problem over here. So our 80 is what the teacher believes. 80 is P equal to 0.85. This is the hypothesized value. Okay. 85% student wants to go to the zoo. What is the alternate hypothesis? The teacher performs hypothesis test to determine if the percentage is same or different from. It is the teacher is not sure whether it is greater than or less than. So they have done P, alternate hypothesis is not equal to 0.85. So this is a two-tailed test then. Two-tailed test. So the sample size n is equal to 50, and the sample success n is, this is your sample size, and x is the sample proportion of success. Sample proportion of success. X is 39. Okay. From which we can calculate P hat is sample proportion of success, and that is equal to X over N. So it's equal to 39 divided by 50. And we can use our calculator to calculate this value. 39 divided by 50 is 0.78. So 0.78. Now, one thing we need to check, n times P0 is equal to 50 times 0.85. Remember, this is your P0 hypothesized value, so it is called P0. Okay, is equal to 50 multiplied by 0.85 is equal to 42.5. And n times 1 minus P0 is equal to 50 times 1 minus 0.85. So if I do it in my calculator like that, 50 parenthesis 1 minus 0.85, it's 7.5. It is not greater than 10, greater equal to 10. So this is greater equal to 10. This is not greater equal to 10. So technically we should not assume a bell-shaped distribution for the sampling distribution of P hat. But for the purpose of the problem, let's assume that the sampling distribution of P hat is bell-shaped. Distribution of P hat is bell-shaped. Okay. Now we calculate the test statistic. Z. Remember, we'll compare the P hat to the hypothesized value of P0, which is the null hypothesis population proportion value, divided by P0 times 1 minus P0 divided by N. So in our case, P hat is 0.78 minus 0.85, here left parenthesis and right parenthesis, divided by second x square gives me the square root. Inside the square root, P0 is 0.85, left parenthesis 1 minus 0.85, then divided by my sample size, n is 50. And that is equal to, so left parenthesis 0.78, okay, minus 0.85, right parenthesis, divided by second x square gives me the square root, and inside the square root 0.85, left parenthesis 1 minus 0.85, right parenthesis, divided by n is 50, and enter. And this is, the z-score is minus 1.38. Okay, so if I move this a little bit up, okay. Since this is a two-tailed test, p-value or probability of obtaining a test statistic at least as extreme as minus 1.38 or plus 1.38 is twice the area. That is important because of two-tailed test. Twice the area to the left of minus 1.38. So p-value will be equal to 2 times area to the left of minus 1.38. So to find that, we go to second button in our calculator, then verse button, then scroll down to normal CDF, low end, lower is a very small negative number on the right is minus 1E99 on the left, I mean, on the extreme left. Upper is minus, remember this minus is next to the enter button in the calculator 1.38 mu, sorry, mean is 0 and sigma is 1. And we do pest and pest. So enter and enter. So second verse 2, lower is minus 1 E99, upper is minus 1.38, minus next to enter, and we paste enter and enter, and it is, so p-value is equal to 2 multiplied by 0.08. You might say 38. So that is equal to 0.0838 multiplied by 2 is 0.1676. Our alpha given, which is level of significance, or the maximum probability of making a type 1 error, alpha is given as 0.01. So P is greater than alpha. Okay. So if we move up, decision, let me change the color of the ink is red. So decision is failed to reject 80. So conclusion is at alpha equal to 0.01. There is not enough evidence to support HA. Remember what is HA? We can move up and take a look at HA. P is not equal to 0.85. Okay. Now there is an easier way of doing it. And let's try the easier way of doing it. So I'll create some space and again do the test. Let's select a color. Okay. Dark blue maybe. Okay. Okay. So use, so this is use TI-84 to do this test, a hypothesis test, where we will not calculate the test statistic. The calculator will do. Okay. So remember our null hypothesis was P equal to 0.85. Our alternate is P not equal to 0.85. Okay. Our X value, if you remember, let's take a look. The X value number of successes was 39, N was 50. So X is number of success is equal to 39. And if I move this or create a little bit space, move this up a little bit. N is 50. Sample size is 50 is equal to 50. Now this is my hypothesized value in the null hypothesis P0. Okay, our alpha level of significance is again maximum probability of making a type 1 error is 0.01. Okay, so we have all the relevant information. Now we will use the calculator to do this test. So first we will press the stat button in the calculator. Okay, so stat button, then highlight means move the cursor on the top row to tests. Okay, and then we will scroll down or move the cursor down by down arrow to one prop. One prop means one proportion Z test. Line up our cursor with one prop Z test and hit enter. So our P0 is the hypothesized value, which is 0.85. Type in 0.85. X, number of success, X is 39. So type in 39 for X. N is sample size, is type 50. What is my alternate? Is the fourth line is PROP. And it should be on the first option because our alternate is not equal to, because we are doing a two-tail test. So it should be on not equal to P0 for prop. Prop is the proportion. That means P not equal to P0. This is your alternate hypothesis. Remember that. Okay. And then we go down to calculate and calculate and put the cursor on calculate and then do the test. Okay, so put the cursor on calculate and hit enter. So our test statistic, Z is the test statistic, is minus 1.39. What does it mean? It means the sample proportion is 1.39 standard deviation away from the hypothesized value. Or let me clear that, is below. This is below because it's negative. Below the P0 value. Okay. Hypothesized population proportion. Notice my P or probability of getting a test statistic at least as extreme as minus 1.39. So P is come out as 0.1656. Okay, so if I create some space, what was the P value previous is 0.1676. So this is close by. Compare that with alpha. Alpha is still 0.01. P is less greater than alpha. Decision, do not reject H0. Do not reject H0. So conclusion is at alpha equal to 0.01. There is not enough evidence to support the alternate. Not enough evidence to support HA. Same as before, but this is much faster and quicker because we are using the calculator to calculate the test statistic. I stop here today. If you have any question, comment, do not hesitate to write me a note. If you like this video, please give me a thumbs up because I make tons of videos. Some of these are good, some of them are not so good. So if you really like this video, please give me a thumbs up. I appreciate that. If you do not like the video, please give me a thumbs down. I can also take that and improve in my next video. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button and let YouTube know that you'd like to be notified every time I upload a new video, okay, in my channel. Okay, see you later. Thanks for watching. Take care. Have a nice day.